So grab your vocab sheet. The intercepts vocab will be used in the first video. The symmetry will be used in the second video, but I'm just going to have you fill in the whole vocab sheet right now so that you don't have to keep flipping back and forth. Intercepts are where the graph crosses the x or y axis. One thing to keep in mind is that an x-intercept would look like x0. Anytime you are on the x-axis, your y value is 0. You moved left or right from the origin, but you do not move up or down. And the opposite for the y-axis, it would be 0. Y would give you your y-intercept. You move up or down to graph on the y-axis, but not left or right. So keep that in mind. That's going to be important when we solve for our intercepts. To determine symmetry of a graph or an equation across the x-axis, you look at the equation, you replace the y value with negative y. If you get your original equation back after simplifying, it has x-axis symmetry. So think about if you have a point up here flipped across the x-axis. The x value is the same, but the y value went from positive to negative. So the same thing we're going to take a look at with our equation. So for y-axis symmetry, if we replace x with negative x, simplify the equation, and we get back what we started with, then it is symmetric across the y-axis. So think about the same original starting point. If we flip that across the y-axis, the y value stayed the same, but the x is opposite. Symmetry around the origin. If you replace x and y with negative x and negative y, simplify and get back your original equation, then it's symmetric around the origin. So one more time, thinking about our original starting point, if we rotate it 180 degrees around the origin, both x and y are negative now. So the first thing we're going to do is take a look at a quick example determining x and y intercepts. So the first thing that I notice when I'm looking at my equation is that I can factor it. So that can be helpful for finding the x-intercepts. So we substitute 0 for y and solve for x. I'm going to go ahead and factor that x out. And then the x squared minus 4 can be factored further into x minus 2, x plus 2. We've got our difference of squares there. And then to solve for the x-intercepts, we set each piece equal to 0 and solve for x. So we get x equals 0, x equals 2, or x equals negative 2. Sorry, I really should have labeled my work. And then I didn't even label which intercept, x-intercept. All right, so next we are going to find the y-intercept. Actually, let me back up one more step. Get used to writing your intercepts as ordered pairs so that you are able to easily graph it. What we're going to do tomorrow or shortly is use the intercepts to get an idea of what the graph looks like. So if we write those as ordered pairs, we'll more easily be able to plot those. To find the y-intercept, you replace x with 0 and solve for y. So in this case, we get 0. If you notice, for our x-intercept, we already had the intercept of 0, 0. So that is our y-intercept as well. As long as it's a function, it will have at most one y-intercept. It would only be if it were not a function that it could potentially have more than one y-intercept. But we're going to be dealing mostly with functions, so for the most part, we will only end up with y-intercepts. Now that I said that, our next one is not a function. So let's take a look at what happens when we solve for our x-intercept. Substitute 0 for y to solve for x. Subtracting 4 from both sides, we get the x-intercept of negative 4, 0. Solving for our y-intercept, we substitute 0 for x to solve for y. taking the square root of both sides. Remember, there's always two possibilities when you take a square root. Negative 2 squared gives you 4, the same as 2 squared gives you 4. So this time we have two y-intercepts, 0, positive 2, and 0, negative 2.